Hello and welcome to part 2 of lesson number 6, where we're talking about object-oriented programming. If you haven't done so already, please download and watch the first part of lesson 6 that's available from the same place where you downloaded this video. We've been talking about classes and objects. Within the context of a class, we've been talking about properties and methods, so we're going to continue our discussion about methods right now. And we've already looked at event handlers as special methods that are executed whenever an event is triggered. So whenever, for example, we have our button 1 and somebody clicks it, we can write code behind the button 1 click event that will respond to that particular event. There's another special method that executes whenever a new instance of an object is created within our application. So when the new keyword is used in C#, you can write code in what's called a constructor that will allow you to initialize the instance of the new object. So what does it mean to initialize? Well, that really depends on the particular situation you're in. It could mean that you set the field values immediately to some default values, or perhaps it'll check in a file or in a database for some information, or perhaps 100 other things. The use of constructors are going to become a little bit more obvious after you start creating object-oriented applications yourself. Let's take a look at how to define a constructor. Let's go to our cars class that we've been working on. Let's go right underneath the properties before the drive method. And here I'm going to paste in some code. You can see I have some comments above this code. Public car with an open and close curly brace. And then notice that I'm referencing my 3 private fields. And then I also have a message box show called the constructor. Let's go back to now our Form 1 code where we create an instance of our car. And let me comment out some of this information here that we've been working with. I'm going to use my little tool here to do that. And let's focus on this line of code. I'm going to set a breakpoint on line 23. And then we're going to run our application. I'm going to click our OK button and begin to step into this line of code. Notice that it's now calling our public car method. Now, why did it do this? That's because car is a constructor. How did we tell Visual C# that we wanted this method to be the constructor? It happens automatically because we have used the same name for our method that we used for our class. Class car, and our method name is car. So that tells C# that we wanted to create a constructor, and we want to run this method whenever a new instance of our car class is created. Okay? It's very simple. Now let's just step into this and see what we're doing here. We're setting make equal to default, model equal to default, elapsed mileage equal to 0. And just for the sake of example here, we're going to pop open a little message box that we called the constructor. And then we're going to continue on and use the car class as normal. Okay? So again, the purpose of a constructor is so that we can have an opportunity to respond to a specific event in the lifetime of our object whenever our object is born, or whenever the new keyword is used. We're going to be able to write some code at that point in time, and we can use that to initialize values, or like I said a little bit earlier, do literally hundreds of other potential things depending on what we want our object to do. Okay, so now let's do this. Let's talk about the concept of overloading. Now, I might be overloading you with too much information right now, but that's not the type of overloading that we're going to be talking about. In object-oriented programming terms, overloading means that we create 2 methods with the exact same name. The only difference is what is called the method signature, or rather the number of arguments or parameters that the methods accept. So let me show you an example of this, and then I'm going to explain why you'd want to do this. Let's take this car method, for example. We're going to create a second car method. The only difference between the two car methods is that the second one, as you can see here on line 55, takes three parameters: make, model, and elapsed mileage. So instead of setting those private fields to their default values, we set them instead to values that the user of our class gets to pass in. So you can see that we're doing that right here. Now let's go back to our form 1 and let's go to the very bottom here and let's use that second constructor, that overloaded constructor. So we're creating a second instance of car called myOtherCar equals new car, and whenever I type in the open parenthesis, notice here that I get a one of two. There's two definitions for our constructor, where we either pass in no values, or if I use the down arrow on my keyboard or the little down arrow here, I can look at the second version of this method called car as well, and I can pass in the string, the make, the model, and the elapsed mileage. So let me do that. So I'm going to type in here Oldsmobile Cutlass Supreme and 200,000 miles. Okay. And so immediately I can do something like this: messagebox.show my other car dot model. And we'll even do this. Whoops. My other car, just so we can separate the two. Okay? So let's go ahead and run our application now. Click the OK button. Let's get rid of this breakpoint and continue running the application. So we call the constructor, and we also called my other car Cutlass Supreme. Now, why did I get two message boxes? Well, let's take a look at that real quick. First of all, we haven't gotten rid of the original code here, so whenever this constructor is called, it's going to call the original constructor we wrote. This line of code here, this section of code, where we're popping up a message box. However, below where we are creating my other car and passing in the parameters using the overloaded constructor, then we simply we don't get a message box until we hit line 58, where we're displaying the message box. Okay, so back to the concept of overloading. Why overload? Well, overloading is something that you do as a convenience. In this particular case, instead of using the default constructor to initialize a value to some default, perhaps I want to have the option to specify the values that are to be used in the initialization of the properties. So I can pass these in as parameters and have them set at the point that the object is first created in memory. So when you think of overloading methods, any type of method, whether it is our constructor method, or we could have done it just as easily with the drive method, think of the convenience of having multiple ways to call the method from the part of your code that consumes your object. So it's just two different ways to do the same thing, and it's offered as a convenience. Whenever you're working with the .NET Framework and using the classes that are contained therein, you'll notice many times that there are overloaded methods and constructors. So just be aware that you can do this too within the classes that you create. Okay, so before we move on too far, I just want to make a couple of observations. In the previous 5 lessons, we pretty much coded everything as a result of a button1_click event, and that was fine. We didn't have to really think too hard about where to place the code, but it really limited our applications. But now notice that methods, event handlers, constructors, and properties all contain, or rather define, code blocks. And a class is the container for these items. You can't just have a method or a property floating outside of a class. There's a certain hierarchy to these sorts of things. All of these structures, methods, properties, and so on, only make sense when defined in the context of a class. Now additionally, a class can reference another class as long as it somehow obtains a reference to another class. It can create a new instance of a class or receive a reference to an existing object through a property or a method parameter. So as you can see in our examples, our button2click event handler, which is simply a method inside our form1 class, it creates a reference to the car class. Our car class, in turn, could create a reference to other classes in our application. I'd also like to introduce another little gotcha. This might be a little complex, so please listen up. Did you ever wonder why we never had to create an instance of the MessageBox class before using the show method of the MessageBox object all over the place? Well, the reason is because the show method has been defined with the static keyword, which means that it's not necessary to create an instance of the class before using that particular method. The same is true whenever we use the int.parse statement. We never created an instance of int. When you define a method with the static keyword, it becomes different from a method that requires an instance to be used. The parse method of our int type was defined obviously with the static keyword, allowing it to be used everywhere. So we could, for example, change our car class and change the drive method so that we wouldn't have to use the new keyword, and it would be available to use at all times. But the problem is that it wouldn't make any sense for the way that we're currently using that particular class and that particular method. We may need more than one instance of the class to define more than one car, so defining drive as static simply doesn't make sense. But we might want to define a new class called utility that might calculate gas prices through the calculate gas prices method. So let's do that right now. Let's go to our add new item, select class, and we're going to call this utility, and click the add button. And inside utility, let's define a new method. I'm just going to paste in our little method here. Notice that I have public static double calculate gas prices. And we could make this a little more complex rather than just doing a simple calculation. We'll leave the business rules up to you, but let's just talk about the structure of the static method. By using the static keyword, I can do something like this back in my form1.cs. I can refer to the type name utility dot calculate gas prices and then pass in 300 miles. So we can calculate the gas price for traveling 300 miles, and I can show that in a message box. And let's go ahead and run our application. We're going to see a couple of message boxes here. Our third message box says driving 300 miles will cost us $105. Okay, so we get pretty bad gas mileage here through our little calculate gas prices method. But the fact of the matter is that I was able to create a utility class that has helper methods that work without us having to create an instance of our utility object. So these are known as static methods, or sometimes referred to static classes if you were to include a bunch of these static methods in a single class, which are different from instance methods or instance classes or instance objects. Okay, if that didn't make a lot of sense, don't worry. Just keep that distinction in the back of your mind that some classes or methods rather, can be defined in such a way that doesn't require an instance of that class to be created first. Let's now talk about the words public and private that keep popping up in our examples. Public and private are types of modifiers, and a modifier changes the visibility of that particular code block. In the context of a class, it refers to something we haven't talked about yet in terms of code libraries. So let's just save that discussion for some other time. But let's focus on the use of modifiers in terms of a class's properties, fields, and methods. Now, when we design a class, we will want certain things to be visible and certain things to be hidden to the code that uses an instance of that class. Those things that are marked with the keyword private will be the things that are not accessible by the code that creates an instance of our object. Now, in the case of field, like we created in our car class, at the very top where we defined our fields, the only way that the code can retrieve and use the value that's stored in these fields is by using its associated property. And notice that those properties are marked as public. Let's play around with this just a little bit and just to see how it works. What if I were to change the underscore make private field to a public field as opposed to a private field? Let's go back over here to our form1.cs. Let's go to the top where we defined all this code. Go my car dot, and now notice that it's visible within the IntelliSense and I can use it. So we'll set the make to Chrysler instead. But notice what happens then if I were to change this back to private. Going back to my Form 1, now trying to run the application, notice that I get a compile time error that says that is inaccessible due to its protection level. Our private field is protected from the outside world, making it inaccessible to the code that attempts to reference it. The only way that it can be referenced then is through the public property of the same name. Okay, so let's make sure we're paying attention right now because this is really important. Notice that while I use the keyword private for my field, I'm using the keyword public, once again, for my properties. That's because I want my properties to be visible by the code that created an instance of my car class. In other words, I want my button to click event, where I created an instance of the car class, to be able to set and retrieve the properties I've defined. It wouldn't make any sense at all to mark my properties as private. That would be completely counterproductive to their whole purpose. It'd be unusable. So you might be wondering, why is there this separation between the storage of a given value in a field with the process of storing it through the use of properties? Why not just make your fields public and then just skip the whole concept of properties altogether? Now, if you're wondering this, you're on the right track. Great job. The reason for the separation is because there is a concept in object-oriented programming called encapsulation. Think about a remote control for your television. Whenever you want to change a channel, you can use the channel up or the channel down button, and that will magically move your television to the next channel. Okay, you really don't want to know how it works. All you want to know is that it skips over the channels you don't want to see, all the channels that don't receive any information. You don't need to see the underlying circuitry that determines the current channel and then sends the signal to the television to change the channel and so on. You just want to use a friendly interface, a single button, and let the complexity be hidden beneath the remote control's plastic exterior. And when you're creating classes, you will want to keep the complexity of how the class works hidden from the code that wants to create and use an instance of that class to accomplish something in an application. So there are some things that you want to keep private and some things that you want to make public. To extend our analogy, you want to provide just a couple of friendly channel up and channel down buttons and prevent the consumer of your class from having to worry about how it works under the hood. This is sometimes referred to as black box programming. And the thought is that a class should be considered a black box that just works. You don't have to see the code in order to be able to use it for your application. Now there's a couple of practical reasons for this. Perhaps you want to filter out values for your properties that are just ridiculous and would potentially crash the application. You would want to separate this. You wouldn't want to just leave these properties out here hanging and let people assign values to them that are just way out in left field. You want to take control of the assigning of that value and be able to filter out bad values. Because by allowing those fields or properties to be set in the wrong order or to incorrect values, it could create a problem within your application. Now, as you're starting out, these might not seem like good reasons to go to all the extra work to create both private fields and then public properties, but I assure you that the principle of encapsulation is very important. So let's extend our example so that you can see how we can modify the make property to only accept certain values that our application can understand and filter out the ones that it can't understand. So what I'm going to do is go to my current make property and comment that out. And right underneath, I'm going to paste in some code that I've written earlier. So you can see here that I have, in essence, gotten rid of the existing set statement by commenting it out and replaced it with a new set statement. This time I'm filtering out all values unless the value equals Oldsmobile or Chevrolet. In those cases, then I will allow the assignment to happen. However, if it's not Oldsmobile or Chevrolet, then we're going to assign it to an empty string. So what we'll do is set a breakpoint here on this line of code. Let's go over to our form 1, and the first time through we'll allow it to set it equal to Oldsmobile. So let's watch the assignment happen real quick. And we'll use our step into, and notice since the value is Oldsmobile, we'll change it from the constructor's value of default to Oldsmobile. And now let's stop the application and change this to Toyota. Just copy this line of code and place it down here. Toyota. Great. Okay, and then we'll do something like this. Message box dot show new value, and then my car dot make, and we'll see if it allowed the assignment to Toyota to happen. Okay, so let's go ahead and try it again. First time through, we'll just ignore it. Let's go ahead and keep running the application. The second time through, however, notice our value. We hit the breakpoint a second time, and our value is now Toyota. Let's watch as the code executes. Notice that it skipped over the assignment because it's not equal to Oldsmobile or to Chevrolet. So we're in our else statement. We set make equal to an empty string. So when we get to the message box, and we're going to retrieve the value in the get statement, and we display our message box, there's an empty string after new value. Okay? So here we've been able to control, for no other better reason than just to make a little bit of an observation here, how to filter out values using the set statement. We've been able to filter out values using the set statement. Utilizing encapsulation to protect the assignment of the underlying private fields, the member properties, to perform a sanity check or to make sure that the values are within an expected range. Okay, so that's a pretty thorough explanation of the how and the why behind adjusting the visibility for your fields and properties. Methods can also be marked with a visibility modifier. When methods are public, they're callable from the code that holds a reference to the instance of a class. When methods are marked as private, they're usually considered what are called helper methods, or rather, methods that perform some small part of the overall function of the public methods in your class. They can be used to break down the function of one big method into smaller bite-sized methods. This makes them more maintainable, more understandable, and some have suggested that no method should be more than a dozen or 2 dozen lines of code for this very reason. So now when you're first starting out, don't worry about this too much. Over time, you're going to start seeing ways to optimize your code, but nobody's going to expect you at this point to remember everything that we said in this lesson. Just keep in mind what we talked about in the previous lesson, that there's no one right way to write code. Some ways are more comfortable, some ways are more expedient, some ways are more elegant, but there's no one correct way to do it. Okay, hopefully this is making some sense. If not, I'd recommend just watch it again. Read some additional things about object-oriented programming. Perhaps watch this video a second time. Give it a few days to sink in, then try some of the examples on your own. Now, when I was first getting started, this was pretty intimidating. But the more that I worked with it, the more that it made sense to me. So don't feel bad if you're feeling overwhelmed. Object-oriented programming challenges everybody at first, but eventually you're going to get it, and it'll be second nature to you. Okay, we said just a moment ago that encapsulation is one of the major tenets of object-oriented programming. And now we're going to talk about another tenet called inheritance. The idea is that when you're creating classes like our car class, you may run into situations where you need a more specialized version of the class. Let's say, for example, let's create a minivan class. Now, a minivan is a lot like a car. Many of the properties of a car can be used to define a minivan. Perhaps there's a few extra properties that could be added to it. And while the drive method still applies, perhaps the way that the method is implemented, the code that's inside the method's code block, should be slightly different. So we could just create a new class and then copy and paste all the code from the car class and put it into the new minivan class. However, if we needed to fix a problem in the code of the car class, we'd need to fix it in the minivan class too. And also there's just a bunch of extra code laying around. It's not a huge problem until we start adding the truck class, the sports car class, and a bunch of other specialized classes that were all created based on the original car class. So is there a better way to do this? Obviously there is. We could just inherit from the car class, which we're going to call a base class, since it is the parent to the other more specialized versions of the car class, like the minivan, the truck, the sports car, and so on. So I could just click on my little Add New Item and then select Class and create a new minivan class here, and then click the Add button. However, that's not what I want to do in this case. I want you to see as an example that the car class defined in car.cs can also contain other classes. So we're going to use this same physical file to define another class. And the way that we can do that is simply make sure that we're inside of the namespace curly brace, but outside of the last curly brace for the car. And between those two, I'm going to just paste in some code that I've already written. So you can see here that I've defined public class minivan car. Let's talk about this for just a moment. First of all, this little notation of the colon means that there's a relationship between these two classes. In fact, the relationship can sometimes be referred to as is a. So it could be read like this: minivan is a car. It just denotes that car is a base class and that minivan derives most of its functionality and specializes the functionality of the car class. So the cool thing is that now I don't have to write all the code that I wrote for the car class in order to get the same functionality inside my minivan class. All I do is just add things and overload or overwrite things rather that make minivans special or different from just a regular car. So you can see here first of all in lines 117 through 120 that I define a constructor, and my new constructor for minivan works a lot differently than the car constructors that I created. Also, you can see beginning in line 123 that I've defined an additional private field and then also a public property called passengers keep track of the number of passengers that it can hold. And then finally, I have overridden the default functionality of drive with my new functionality where I'm also calculating the cost of driving the minivan and adding that into the result string. Additionally, I've got some other text in here, mostly to soccer games, costing, and then how much it cost. So let's go ahead and save this. Now, I want to talk about a few things here before we get started. Notice that I still can reference the make, the model, and the elapsed mileage even though they're private fields. Now, that's actually a misnomer. I do have to make a small modification to my car class and change the visibility to something called protected. This allows only those classes that derive from the car base class to access the values that are denoted here, so protected. So it's somewhere between private and public and used whenever we're working with inheritance. Okay, so now let's do this. Let's go to our Form 1, go under the Button to Click event, and I'm going to paste some new code in here. So you can see I pasted in lines 31 through 39, and it's obvious that I have a little bit of a problem here. I did this intentionally so we can talk about that. But I've created a new instance of my minivan. Even though I didn't define the make, the model, and the elapsed mileage properties of the minivan, notice that I still can refer to them because of the relationship to the car class. I can also reference and set my new passengers property, and I'm calling my new overridden method drive. Now this seems to be where the problem is at. It says there's no overload for method drive that takes 0 arguments. Oh, excuse me, and maybe I forgot just to do this. Let's see if that works. So we'll type in the number 30 here and we'll try to run our application. Okay, now notice that we are get a few little error messages here. Well, it says that if we want to hide the previous functionality of drive, we have to use the new keyword. So let's go back to our car class. And so in this case, we want to use our new drive method instead of the old drive method. They have the exact same method signature, so we have to tell CSharp that this is what we intended to do. So we're going to use the new keyword right there. Then it also says we have a little bit of a problem with our toString. There we go. It was just the wrong case. No big deal. Let's try to run our application again now. Click our OK button. Notice that we get the constructor message twice. We'll talk about why that happens in just a moment. And we get the town and country now has 2,530 miles, mostly to soccer games, costing $10.50. Okay. So the real question is, why did we get two of our little pop-up messages called constructor when the first time we call it should be here, but the second time is not very obvious, because why would it call the constructor for the minivan when we've already defined a constructor for minivan? Well, let's set our breakpoints in a few spots here and watch as the code executes. So I'm going to go back to cars. I'm going to set a breakpoint here and in the car constructor, and then I'm going to set another one here in the minivan constructor. So let's run the application again. Click the OK button. Okay, the first time through, it's going to call it for our, I'm going to use the step out button here, call it for our new car. But let's keep stepping through our application here. And in fact, let's just step out of that and then step over all these lines of code. Now let's step into this line and notice that the first thing that does it does is that it calls the minivan constructor just like we wanted. But then the next thing that it does is that it calls the car constructor. It's again because we're deriving our minivan from the car class. It sets all of these, shows our little constructor, and as we continue through, then and only then will then execute the rest of the code within its constructor, changing the value of make from default, which was set in the previous constructor, to the new value NA, not applicable, or whatever the case might be. Okay? So that is something to keep in mind. Whenever we're working with constructors in a derived class, whoops, let's get to the right place here. Whenever we're working with constructors of the derived class, the constructor of the base class will be called before the constructor of the derived class. Now there's a lot more to inheritance, and we've really only scratched the surface. But you can see the basics of inheritance and how it works from this simple example. We're coming to the close of this video, and I decided to wait until now to point out some of the benefits of object-oriented programming. As I said earlier, these might not be very obvious at first. After all, it seems like it would actually make your life a lot more complicated. But as you develop applications, you're going to begin to see where approaching application development using object-oriented principles can actually make things easier. First of all, the benefit begins when designing your application. Object-oriented programming starts with analysis and design. It provides a logical way of breaking down a big problem into small, easy-to-digest, bite-sized pieces. It's easy to think of the major classes of your application and then start adding properties and methods to each of those classes, charting the interaction between the classes, and so on. There's a whole set of methodologies created by various people to help you through this process, but that's a little bit outside of the scope of this series of lessons, and quite frankly, it's a little too early for you to worry about. Just thinking in terms of objects sometimes makes conceptualizing how to construct a program a little bit easier. Second, if you keep everything related to a car, in this instance, in one class, it makes it easy to change how your application functions by just changing the code in one place. Let's just assume that you wrote your application in a very haphazard way. You've got many places in the application that allow the user to modify data related to the car. Then one of your boss comes to you one day and says that you need to change the way the application modifies the car data. Now you have the unenviable task of searching through all the code that you've written, through dozens of forms and files, to find where the car data is modified in code. And once you find that code, then you need to carefully change it, hoping that you didn't miss anything or forget something. Because if you miss some of the code that needs to be changed, you've really got problems now. At the very least, you would have created a lot of extra work for yourself and caused the application to be larger than necessary and made it more difficult to update. Taking a more object-oriented approach, you would just change the method in the car class that modifies the data, and you're finished. If you've introduced a bug, no big deal. You've isolated it to a single spot in your code. Which brings us to the third benefit. By encapsulating functionality in your class, the code that creates and uses an instance of your class might not have to be changed, even though you update how your class operates internally. And then there's also the potential benefit of reusability. Since your car class is modular, all the code related to a car is in a single class. You could copy that class file and use it in different projects. You wouldn't need to rewrite any code in order to gain all the benefit of your car class. You've already worked out all the bugs, so that saves you a lot of time in designing, developing, and debugging the new code. Okay, so there's a lot more that I could talk about, but we've already been talking about this for over an hour, and I suspect that your head might be spinning at this point. So I recommend two things. First of all, watch these two videos again that comprise Lesson 6, and try to follow along with the examples. Pause the video when you need to try something. Really take the time to work through some of these ideas. Also, I recommend taking a look at the additional readings that I put together in the accompanying document for this series of lessons. Also, search online for more information about some of this stuff. The quicker you get this under your belt, the quicker that you're going to be on your way. I really encourage you to not make it harder than it really is. Don't feel like you have to understand this 100% before you can be productive. That's simply not true. Like I said at the outset, it might take months or years before you master some of these concepts, before you see the value in using this approach towards building your applications. This is really just the first step in a journey, so by all means, don't get discouraged. Don't let it stop you from building applications, even if you're not building them completely object-oriented. Just keep plugging away. Before you know it, you're going to know everything that you need to know. So I hope you enjoyed this video and this series so far. If you've enjoyed it, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic, ASP.NET, and more. Thank you.